Hi guys, welcome to Science in 5. In this video we're going to look at this question 1. It says k of x equals ax squared plus bx plus c, quadratic function, coupled with h of x equals minus 2x plus 4, linear function. Minus 118 is turning point of k, there it is. S is x-intercept of h and k, there is s. K and h also intersect at t there. Calculate the coordinates of s. Now, to calculate the coordinates of S, the intercept of h and k, we can use the equation given for h of x. So for number 1, we know that an x-intercept means y equals 0. So this is going to mean that 0 is equal to minus 2x plus 4. Remember, when it comes to the algebra of functions, generally use the y format. The function notation is handy, but use the y format. Okay, so now all I have to do is simply solve this equation. Subtract 4 from both sides, divide both sides by negative 2. I'm going to get x is equal to 2. But I want the coordinates. So the x value there is 2, the y value is 0. So therefore S is 2, 0. Fairly straightforward, guys. Okay. 1.2, determine the equation of k in the form y equals ax minus p squared, the turning point format. So there's something missing from this equation. Okay. Y equals ax minus p squared plus q. Remember, guys, teachers also make mistakes, examiners make mistakes. Come on. Right, so there's a plus q there. So p and q are the coordinates of the turning point. But remember the trick with p, we always take the negative value. So here it's negative 1. When you transfer it, it becomes a positive 1. So number 2, I'm going to say y is equal to a x plus 1 squared. The y value, always take it as is. I'm almost finished, but now I don't know what a is. So to get the value of a, I need to substitute another point other than the turning point. I've just calculated the coordinates of s, which is 2, 0. So let's substitute that. So 0 is equal to a into 2 plus 1 squared plus 18. 2 plus 1 squared is 3. 3 squared is 9 times a becomes 9 of a plus 18. I can easily solve this equation. Bring the 18 across, becomes negative 18 is equal to 9a. Divide both sides by 9. I get minus 2 is equal to a. Therefore, my equation now is y is equal to minus 2 of x plus 1 squared plus 18. This is my answer there. Okay. Now, y equals minus 2x plus 1 squared plus 18. Then the third question says, if k equals minus 2x squared minus 4x plus 16, determine the coordinates of t. Normally, if you find questions like this, whether it's in analytical geometry or it's in your maths where they say to you, determine what k is, then the next question they say, if k equals, they're actually like giving you a tip that your k should be that. So this equation, if you expand it, it should give you that. Okay? All right, so you can clearly see the a values are the same, but these two equations are the same. All right, let's now calculate the coordinates of t. Now, to calculate the coordinates of t, we will need to equate these two equations together. S and t are the points of intersection. This is where the two graphs are equal. This is when the y values are the same. This is where the x values are the same. So let's do that. So what we're going to do now for number 3, right? We're going to say minus 2x squared minus 4x plus 16 is equal to minus 2x plus 4. We are equating these two equations to each other. So we're going to solve for the x. So the negative 2x comes across, becomes a positive 2x. So it's now minus 2x squared minus 2x. 4 again comes across, becomes a... In fact, here I jumped. Negative 2x becomes a positive 2x. Right? That's it. Negative 4x plus 2x is that. The 4x becomes a negative 4. It's actually a 4 becomes a negative 4. 16 minus 4 gives you a positive 12. Now that is now equal to 0. Quadratic equation. I can factor out negative 2. I remain with x squared. Negative 2 comes out. Negative and a negative becomes a positive. So it's now x squared plus x minus 6 is equal to 0. Okay? Remember, again, just to check if this is correct, once you take out the negative 2, divide each factor by the negative 2. Negative 2x squared divided by negative 2 is a positive. A negative divided by negative should give me a positive. A positive divided by negative should give me a negative. Now, divide both sides by 2 equals 0. I remain with this equation. I can actually divide the two sides by negative 2 to get rid of the negative 2. So now I want to solve this equation that says x squared plus x minus 6 is equal to 0. It should be fairly easy to solve this. We've spoken of how to solve quadratic equations in one of our videos, so this should be straightforward. You can get two brackets, put x and x. I can see that the last term is a negative, so I'm multiplying a positive and a negative to get a negative. Two factors of 6 with a difference or sum of 1, it's 2 and 3. Okay? 3 must be the positive number and 2 must be the negative, because 3 minus 2 will give me 1. So I can see that x equals minus 3 or x equals a positive 2. But x being equal to positive 2, we've already found out that coordinate, that was s. So t must be the other x value, which is the negative 3. So this value here is now the negative 3 value. But we want the coordinate. So in other words, now we need a y value. So to get the y value, just use one of these two functions to get the y value. I normally go for the easy one. So now I'll say the function value when x is minus 3, h of minus 3 is going to be minus 2 times minus 3 plus 4. Negative times a negative is a positive 6 plus 4 gives me 10. So now I've got my two values, negative 3 and 10. And so hence t is now what? What's the x value? Negative 3, y value 10. Okay guys, so that's how you can attempt a question like this. Remember, in an exam setting, I'll advise you always to read the question. Sometimes questions give you clues, like this one, if k equals that. So as you work out your answer here, you can actually check, does my answer come to this? Okay, if it does, then you're fine. If it doesn't, then something is amiss. Okay guys, it's been fun. Thanks for watching. I'll see you again in another video where we discuss more about quadratic equations. For now, sharp sharp.